All right, boys and girls. Welcome back to the drive-through. Hope everyone's having a great day. Welcome to Chapter 3. Okay, go ahead and pause the video and read the situation here. It's a quick little lesson. All right, so what I'm going to do is color code these things. So each color that I'm touching on will correspond to the activity that's going on during this color period. And then we're going to need a different color for take a break, so we'll do that one last. So Sylvia is draining her pool. Then she's going to clean her pool. And then she's going to take a break. Okay? So at first, there was water in the pool. So we're going to have to start with our y-intercept being somewhere up here. This would be the maximum amount of water that was ever in the pool. And she's removing it with a single bucket. So if this should be a step function. Every bucket she takes out, that's just a little too much. Every bucket she takes out, a little bit is taken out. So it's like steps. We're taking it out by the bucket to start. Okay? That would be a discrete function. Okay? Well, after that, they drained water with a hose. So that would be continuous. Maybe it was like about the same rate. But now, it's continuous. Well, then Sylvia and her two friends removed water with her 3 buckets. So at that point, we started removing water more quickly. Because we have 3 times the buckets that we did before. Okay? Filled the pool with a hose. Why do they do that? I don't like that. We don't want to fill the pool yet. So then they cleaned the empty pool. So let's say they kept doing that until they were done. Okay? Well, during the red mark, this is the empty pool, so they're just cleaning it. So there's a little water in it, and then there's no more. I don't know how long it took to clean it, but this should be a nearly horizontal line. And then they took a break. So then this line is definitely horizontal. They didn't take that long of a break because they're hard workers. And then what did they do? Well, they filled the pool at the same rate. So now this slope was negative. Now we got to match that rate, but in the positive direction. Until, let me move this, until when they were finished, the level of water in the pool was the exact same. Okay. So now let me take this and see if I can grab that. Let's see, let's grab this. And that's kind of an idea. Okay, now let's talk about, it's going to ask you, was this a function? Well, let's just forget about that for a second. Let me know if the graph is a function. How do we know if the graph's a function? Let me give you 3 different functions here. Well, not 3 different functions, 3 different graphs. How about 4 different graphs? Y equals 2x plus 5. That's going to look something like that. It's going to be a straight line. How about y equals 2 times 5 to the x? That's going to look something like that. Okay. How about x squared plus y squared equals 25? That's going to be a circle. Now you don't know that, but we're just looking at 3 graphs here. We have a purple graph, a blue graph, and a black graph. How do we know which one of these are functions? Well, specifically, a function could be written in terms of y equals a function of x. So that is a function, and that is a function, and that is not a function. But how do we know? There's a really easy test. We go to the graph. If we can draw vertical lines anywhere on the graph and it only touches it one time, then those are a function. I want you to take notice. This vertical line touches my circle here and here. It fails the vertical line test. Where if you look at any other vertical line, that one touches it here, that one touches it here, that one touches it there. Those are all singular points. So the blue curve is a function. Let's look at the black one. Here, 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 here. The black line is a function. It only touches vertical lines once. So this is a very important part. You should definitely add that to your notes, the vertical line test. If we can draw a vertical line anywhere on the graph and it hits 2 points, then it is not a function. Very important. Okay, now we're going to just do some practice with some activities that are going to be important. So how to solve equations. This is a linear equation of some sort. Notice we have to get all the x's on one side. So to do that, I'm going to subtract 3x from both sides. That leaves me with negative 2 equals 7x minus 72. Okay, add 72 to both sides. You get 70 is 7x. Divide each side by 7. And you get x equals 10. Let's check our answer. On the left, 30 minus 2 is 28. On the right, 100 minus 72 is 28. That is correct, so I know I did it right. At that point, I will circle my answer so I get full credit. This says 10x squared equals 250. If you remember, please excuse my dear Aunt Sally. When you're solving things, you want to undo them backwards. So there is no addition or subtraction going on. There is no division, but there is multiplication. So let's get rid of the multiplication first. Divide each side by 10. Okay? Gone. You get x squared is 25. Well, what number times itself is 25? 5. Be careful. Or negative 5. What's negative 5 times negative 5? 25. With 25 times 10, 250. So it's both of them. Here's a hint. If you have a squared, there might be two answers. Okay, finally, x to the 6th is 4,096. We don't know how to do this, so we are going to have to guess and check. It's a good time to learn how to use our calculator. Okay? Let me pause the video. Okay, so we know that 1 to the 6th is 1. Maybe it's 2 to the 6th. 2 to the 6th power equals 64. Not even close. Let's try 3 to the 6th. 3 to the 6th power. 729. Let's try 4 to the 6th. Let's try that again. 4 to the 6th. There it is. So, x equals 4 in this. But hold on. What would negative 4 to the 6th power be? Let's test that. Let's get back to our calculator. Now, negative 4 to the 6th power. Ooh, we can't put it in that way. Watch. What about negative 4? Whoops. Negative, parentheses, negative 4 to the 6th power. Well, that is also a positive. I'm sure some of you are a little confused about this. You might want to just do this and you're -4 times -4 times -4 times -4. Do that in your calculator. Okay? Or maybe you know that every time you multiply two things by a negative, it's a positive. So this will be a positive, then a negative, then a positive, then a negative, then a positive. So if we have anything to an even power, it's always a positive. Okay? So there's a lot of learning there. You guys are doing great. All right, how do we graph y equals 3x minus 8? Well, what is our slope? It's 3. What is our y-intercept? It's -8. So the easiest way is to go down 1, 2, 3, 4, 5, 6, 7, 8. Start at -8. Go over 1, up 3. Over 1, up 3. Over 1, up 3. Okay? Get your straight edge. I can't use a straight edge on this machine anymore, which is okay. So let me use this line tool. It's going to look something like that. Okay? How do we graph y equals 3x to the fourth? Well, I don't know. I think I have an idea. This is the base, so it's going to start at 3. And then this is the rate. But the easiest way to do this is in our graphing calculator. This is why we have you get them. So y equals 3. Just type it in exactly how it looks. Parentheses 4 to the x power. Graph it. That doesn't help us. Let me go to a standard window. Zoom. 6. There we go. That still doesn't really help us. So look, instead of using your graph, use your table. Now those numbers are huge, huge. So just get 3 numbers that are going to be on here, and let's pick. Let's make every one of these. Let's make these worth 1. Let's make all these worth 10. So up here is going to be 100. And 20, 30, 40. This is going to be 50. Let's go back to our table. All right, so 0 is 3. Starts right around there. I don't know if you guys can see this. I hope you can. Okay. 1 is 12. 2 is 48. So 1 is 12. And 2 is 48, just short of 50. Well, now I got an idea. It's going to go from here. It's going to get big fast. And that's the best I can do on this ViewSonic. Okay? What about y minus 2 equals 3 times x minus 4? I don't know what the heck that is. If you're doing awesome, you might recognize this as point slope. But if you don't like point slope, then make it look like something that you do recognize. So let's go y equals. Y minus 2 is 3x. Be careful. Plus 12. Add 2 to both sides. You get y equals 3x plus 14. Ah, no, I can just type that in my calculator, and I love that. 3x plus 14. Give me a table. 0 is 14. Well, I'm going to have to go up here. So, -4, comma 2. That's just my way of making a point on this stupid program. -3, comma 5. Oh my gosh. This thing is going to make me quit teaching. -3, comma 5. There'll be a point here if it ever works. There'll be a point here. Let's go to the calculator for one more point. -2, comma 8. -2, comma 8. Okay, we'll get our line tool going. And there we got the graph of that line. Notice that line contains the point 2, -4. No, sorry. Okay, we're good. We're good.